There will be activity this morning, I promise. Test 1, 2, test, 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 test. Go. Wow. We have the heaters on here this morning because it was really cold when I got in here this morning. Yeah. Have you been here before in the classroom? Yeah. Yeah, yeah, yeah. Which way, how far, how long? Those are the rudimentary questions we must ask whenever we're flying an airplane from one place to another. Which way? That's what you guys did on your sectional maps. How far? That's kind of what you distanced on those things, measuring your distance. Well, we kind of need to know how long, right? Time, speed, and distance. The mask is about to go back on.
I just sneezed.
I get it.
I feel like I'm a dog in a cone of shame for protection.
That's exactly, because sometimes we have to protect you from yourself and protect us from you.
You can't see me smiling.
This has kind of become the tuberculosis ward here, I think. Yeah.
We should give her one for
We very well should. Well, you came to the school, so yeah, kinda. All right, I'm going to put you all out of your misery here.
Thank you. I might have done it. I might have. I really might have done it.
Wait, I want to keep going.
No, we don't have time for you to keep flogging around on this thing. What was your assignment last night?
Read that.
Huh. It wasn't just read the instructions. It was do the problems. Right? That was your assignment. Am I right? Guys, it's like I can't and I won't tell you again. That's not the way this class works. We will not get to the finish line if I have to keep stopping to do this. So, can we all agree? One last, final time in front of reporters and everyone that we're going to do the assignments. Okay? Can we do that?
Yeah.
Can I get a verbal amen?
Amen.
Thank you very much. All right. So, in order to solve these, we talked about this yesterday, and I will turn your attention, and for those of you watching at home now, painfully, is that we're looking here at the calculation side of our trusty E6B, or as it was known in World War II, the whiz wheel. Yeah, it's been around a while. So, we understand that we have three elements that we're working with. We're working with time, speed, and distance. So when I look here at at the whiz wheel, we have 3 rings, correct? What is this outermost ring? Alpha. The center ring? Bravo. Charlie. Okay? So we have numbers on the outside, we have numbers on the middle, we have this thing that looks oddly like time in that Charlie ring, right? Okay. Then we have that big triangle thingy on there. What is that thing called?
The rate time.
Okay, it is either your rate arrow or your index mark. Okay, so rate arrow, ding, 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 ding. What do you suppose that rate arrow might help us with?
What is your speed?
Rate, correct. What is our rate that we're flogging this airplane through the air? Okay, and in this particular case, we need ground speed, correct? Ground speed,
Yeah.
right? Okay, so for the rate, we know that that arrow has to point at a number, okay? But does it always have to point to the rate? Because if we know the rate and we know the distance, what are we solving for? The time. If we know the rate and we know the time, what are we solving for? The distance. And if we know the distance and we know the time, what are we solving for? So the rate. Because again, this is going to be the things that we do. We solve for the unknown. Are we good so far? All right. So let us say, for instance, that you are traveling at the blazing speed of 90 knots. Your ground speed is 90 knots. Don't look at your computer. Don't look at your computer. You're traveling at 90 knots. You know your rate. You know that your timing-wise, your timer tells you that you have been traveling at that rate for 30 minutes. How many miles have you gone? What's half of 90? 45. So have you gone 45 miles?
No.
No?
Oh, never mind.
Who says yes, we've gone 45 miles? I see I see 2 halves of hands. I think we have a hand and a half. Okay, there's 2 hands. All right, we've got that. So how would we test that? Just based on what we know. Not looking at this, but engaging the supercomputer first, and then working on the problem itself. So let's go to something that we do know. 60, right? So if our rate is 60, and we're traveling for 30 minutes at a rate of 60, whatever that may be, 60 knots, how far have we gone in a half hour? We've gone half our rate, right? So there's 30. So if we're traveling at 90 for 30 minutes, half an hour, half our rate is 45. Well, let's test that. So here's what I want you to do. On this whiz wheel of yours, I want you to put your index mark at 90. Put your index mark at 90. Whoops, come on. Every time I let go of this, it moves. Put your index mark at 90. Okay? Now then, your distance is going to be indicated on the alpha ring. Your time will be indicated on the Bravo ring. Set your index mark at 90. Does everybody have it at 90? Now, from that 90, do not spin the wheel, turn the entire mechanism until you can read the number that is above 30 on the Bravo ring. What number do you see adjacent to 30 on the Bravo ring? 45. What do you think that 45 is? That has been your distance. And your time is in the Bravo ring. So your distance is in the alpha ring, your time is in the Bravo ring. Correct? Okay? So, the first thing we do is we say, what number makes sense? Because this is going to be the problem. The problem is that you have to first of all pass the gut check. because you're using the whiz wheel or your circular slide rule to test what this is telling you. So let's check this out. If I tell you that you're traveling at a rate of 120 knots, that's your ground speed, 120 knots, and you want to know how far you have gone in 15 minutes. Now, don't even look at it. Don't look at it. Don't look at it. 15 minutes is a quarter of an hour, right? What's a quarter of 120? 30. Okay? Now, set your index mark on 120. Put it right there on 120. Oh, wait a minute. I don't see 120. What do I see? 12. But we know that we're working with ratios, so we can make that work, right? Okay? So, there's 120. Now then, I want to know how far I have gone in 15 minutes. So what do I need to do here? I'm going to find 15 minutes on my Bravo ring, and I'm going to look then adjacent from the Bravo ring at the Alpha ring to determine how much distance I have covered in that 15 minutes. See what you got? Okay? Kind of see how that works? Now then, let's say this. Let's say that you have traveled on a course that you know to be 35 miles. You know the course is 35 miles. And you know it's taken you 20 minutes to get there. And you need to know what your rate is. So how would you solve that problem? 35 is the distance, 20 is the time. Tell me then what your speed is. 105 knots. Does that pass the gut check with this? There's no. Look here. 35 on the Bravo ring. You see 35 on the Bravo ring here? You see that? See 20 across from the Bravo? 35 on the Alpha ring, 20 on the Bravo. I said 20 minutes, 35 miles. And then you look at your index mark. That points to your what? Rate. Good so far? Yeah. Now then, for the sake of all things holy, I'm giving you 5 minutes to solve that. Go. We'll find out. So this is what you're solving, given your newfound knowledge. That is one big lens now. I said, man, that thing is huge. That thing is huge, man. It's big, that's all. That's all I'm saying. I don't mean nothing by it. I'm just saying, man, that thing is huge. If you want the kids doing something, if you want them, whatever, just tell them. Because this is the day for them to be told. Yeah. My God in heaven. What is that? What this is, this is something that we use in aviation. This is technology before that doesn't need batteries. Yeah. So it's called the E6B flight computer. Okay. And what we do is that the calculations that we use in the airplane is, we always kind of have to consider what happens when stuff shuts off in the airplane. So what is it that we don't have to rely on batteries for? So with this, we can use calculations in the airplane whenever we're doing cross-country flying. We do it in pre-flight as well as en route. And what we do is we use this so that we can determine, are we going as fast as we think we are? We can also use this that they're going to use here in just a second for determining what our wind correction angle is, you know, when the wind is blowing and we have to determine what's going to be our course. So we do wind correction angle problems, fuel burn, true airspeed. We can also do conversions. We can convert from Celsius to Fahrenheit and with things. But this is just kind of a rudimentary tool that we use. And the reason that we do it this way, as opposed to doing it with like more automated features that we have, is they need to understand the underlying math and science behind the problems before I just let them start pushing buttons.
Yeah.
Because if they're willing to accept what a machine tells them, well, in some case they do so at their own peril. I don't want to say peril in this thing, but they, you know, Gavin knows I'm right there though, right, pal? We don't want iPad in command. We want pilot in command. That's what we're after here. And so this is one way that we can ensure mathematical understanding before we actually start using automated systems to help us in this planning.
Okay.
Early on, when these kids are flying, what they will find is that it will take them longer to plan their first cross-country flight than it will for them to actually fly it.
Yeah.
It does. But then once they go through the exercise and they understand everything that's involved, this leads to proficiency, it leads to safety, it leads to all of these other crazy things that we hold dear here. So anyway.
Interesting.
And then we use these things, we apply these things on our simulators, we apply them in the airplane, and that's the point of everything here. It's applied math and science, and this is what we're doing here right now. They're learning another way to do algebra in their head. In the course of what we do here, we teach them how to do trigonometry in their head with glide slopes. With this is what we do. You know, and you think about this.
Time since I've seen that.
Oh, I know,
Yeah.
I know. And this is the thing.
Yeah.
But what we do is that we talk about it. We talk about all of the elements involved, and then we actually fly it.
Okay. Cool.
So that's what we do.
Making math a little more interesting.
That's our goal.
Yeah.
I do. I really think I have it.
All right, Tyler, do me a favor for just the love of God. Can you help Story, please? Because she's like, my Lord, it's painful.
Okay. So number one is
Freshmen through seniors. Yeah. This is the high school. This is what we call the integrated private/instrument rating course. So it's the private pilot and the instrument rating course all in one.
Okay.
It's a year-long course.
wait, Cooper, what'd you get for the first one?
And what it does is that it offers 2 different industry certification levels at the end of this course. So in May, these kids, we go to Grand Junction and they'll take 2 FAA exams. They'll take the private pilot exam, they'll take the instrument rating exam. And so that's 2 forms of what we refer to as industry certification that we have here for this. And this is, you know, when you talk about STEM or STEAM or whatever, you know, we call it aeronautics because I'm snooty that way.
Yeah.
Is that something that leads to some form of industry certification. And in this case, with everything that I do, it all leads to some form of FAA, Federal Aviation Administration. Sorry.
No, you're good.
We use acronyms way too often.
Yeah.
But that's what this leads to, is industry certification here for these kids. And hopefully a better understanding of the math and the science that they learn in other classes that we can apply here. And even here, perhaps they can also, you know, the hope is that you have the corollary between what they learn here and can apply elsewhere.
Yeah.
So,
Is this an elective class?
yes.
Okay.
Yeah, this is not this class is way too hard for it to be a mandatory class.
Yeah.
Yeah, they get college credit for this class.
Oh wow, nice.
Yeah,
Okay.
yeah, because it's tough. These are, These are two of the study guides that go along with this class. The textbook is 892 pages. The far aim, it's the stack of books that goes along with this class. If we actually used paper, it'd be over a foot high.
Oh, wow.
But we use electronic versions so that because they carry them in their backpacks, and so to try to save their spines, that's what we do. Is we do almost everything that we have electronically, where we can. But these guides, we do this in paper, and then all of the testing that we do is all electronic, because the FAA testing that they will do is electronic, and so that's why we do all of this.
Okay. Do you know the young girl on the very far end?
Steph Wojcik, Stefani. Yeah, Stefani. And her last name is spelled Wojcik. I want to make sure I'm not lying to you, hon. Give me just a second here.
Okay, perfect. And she's in ninth grade.
She's freshman, yeah. Yeah. Table number 1 over there. Those three are all freshmen.
Okay.
Freshman girls. We're missing half our class here.
Yeah.
They're sick.
Mr. Rock, should I take off the mask?
Go ahead and take off your mask. Yeah, that's fine. Stephanie's already made us all sick anyway. It doesn't matter. Okay.
I think you made me sick this morning.
What's that?
I think you made me sick.
Oh, no. Yeah, did I make you sick?
Yeah.
It's about time. He made me sick on XN.
That's why I wasn't-
So I wound up with pneumonia because of that kid.
Thank you. I don't. You sick? Well, you got pneumonia again, so I think that's just.
I know. I think I'm just weak. I'm just soft. I'm just soft. Yes.
We have a question
We have an answer. Let's see if they match.
about the last one.
Okay, hold on. We're going to work these out here in class.
Okay.
I want to give you guys, I'm going to give you another 60 seconds.
Oh wow.
Yeah, I think I'm right about this one. That's not. I just did it again.
Yeah, but the numbers in secret is 55, 50. It's 55. There's 20.
Wait, so then we'll, okay, wait, hang on. So then, that would be 450. 450 knots? Jesus, that's not right.
I think it's still 407. I mean, yeah, 20.
So that's right there.
No, that was 525. That's 520. Because that's the long lines are 510, 20, 30, 40.
All right, guys, here we go. All right, now, let's take a look.
Yeah, but it's 500 to 500.
And back to me. Now then, let's take a look at the top line. Speed, time, distance. What are we solving for? Time. Now, we know our rate, correct? What's our rate? 125 knots. We know our distance, correct? Okay? Now let me ask you a question. Before you even look at this, before you even look at it, how many times does 125 go into 500?
4.
Thank you. So we know that right now we're talking about something that's just over 4 hours, right? Okay? So we know it's just over 4 hours. Ding, 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 ding. Good so far. So what do? Tell me what to do. Tell me how to solve this. Set my rate on 125. Does that look like 125 to you? Yep. Okay. Now what? Where do I see my distance? Distance is where?
Alpha ring.
It's on the alpha ring. So I'm looking for something that starts with a 5, right? So 5, 2, 4. Okay, so you see 50? You see 50 over here?
Yeah.
Okay? Now, if you look there, because this is a little tough. You've got 500, and then the next one, the 55, is 550, right?
Yeah.
So what are the little hash marks? What are the little tick marks?
The long ones are 10.
Okay.
And the short ones are 5.
Okay, so we know 524. So where's that little tick mark going to put us?
2 long ones and a little bit before the short one.
2 long ones and not quite a short one. Thank you, Tyler.
You're welcome. This is not how I do it.
This,
I'm doing well.
this is all about precision here with this. Okay, so now we know kind of where we want to look on that alpha ring to look adjacent at the Bravo ring to solve this, correct?
Yes.
Now, we said we know that it was going to be just over how many hours? Just over 4. Look at your Charlie ring. Do you see your Charlie ring?
Yeah.
See 4?
Yeah.
What'd you guys come up with?
411.
4 hours and 10 minutes.
411? If I were to plug this into the computer, it would come out to 412. So if you look at that, 4 hours and 11 minutes, that's close enough for cross-country jazz. Does everyone understand that? Good so far. All right, thank you very much. I appreciate the respect, Steph. Props. Nothing but love for you. Next one. All right, next one, we know the time and we know the distance, correct?
Yes.
Now take a look at your Charlie ring. Do you see something that says 2 semicolon 30?
Yeah.
You think you might want to use that? Think so too. Okay? So we look at this and we see the distance. We know the distance is going to be on the alpha ring, correct? So how about this? How about if I slide my rings around here so that 230 shows up on something here at about 345. So there's 34. There's 35. Well, guys, it's not going to slide that great for me here. I apologize, 230. Because every time I move my finger, this little sucker moves. Okay? So what are we solving for here now? We want to know what? We want to know our rate. So what did you guys come up with regard to your rate?
136.
Okay? I looked at this and I came up with like 137. What'd you get?
I got 86, but I think, are you supposed to do the 2:30 lined up with the 34.5?
34.5. Do you see?
I did the rate lined up with 34.5.
Okay, and that would be incorrect, wouldn't it? Then there we go. Because it doesn't pass the gut check. If you look at this, you know you're going just over 100 miles an hour. If you look at the distance that you've covered in the time. So with this, I got 137, the book shows 138. 138. It's just a matter of fractions on this. So again, with this, we're getting close. Got it?
Yeah.
Next one. We know our rate, we know our time. Now we're just solving for distance. Stop, stop, stop. Don't even look at it. You're at 110 knots. Your time is 140. Let's round this off. Let's say you're going 100 miles an hour for an hour and a half. How far are you going? 150, right?
Yeah.
Okay? So with this, I'm going a little faster and I'm going for a little bit longer, right? So I want something north of 150. Okay? Carry on. What do I do? Tell me how to do it.
So you set your rate to 11, which will be
110. Do you like that? 110? Okay, there's my rate at 110. I'm looking for what? 140. Oh, would you look at that? Do you notice how 140 kind of lines up right there with that little 10 marker right there? Okay, you see that? On your Charlie ring? See how the 140 on your Charlie ring? See here? Right across here from your 10. Look at that. See your marker? So here's 1/8. So I've got 180, right? There's 180. Here's 190. 180, 20, 40, 60, 80. So those are 20. So what do you think? What do you like? 1/8 tree. 1/8 tree would be correct. 1/8 tree. We say stuff funny in here. Tree. Okay? We good so far? Oh, oh, illumination. Oh.
I always thought those were like a tree. Okay. I thought it was 180.4. Yeah, or 0.3. But no.
Negative. Okay? Next one. Let's take a look at this. Look at it. Look at it. Don't solve it, but look at it. Let's round that to 20 minutes and 40 miles. If I go 40 miles in 20 minutes, what's my rate? Who says 120? Oh, I'm sorry. No. Half that. Going the other way. Sorry, I'm going way slow. Okay? No. That's right. 20. Yeah. So if that's my rate, if my distance is twice my time, I know that I'm going 120, right? Because if I were going 60, I would go 20 miles in 20 minutes. But if I'm going 40 miles in 20 minutes, I know I'm somewhere around that 120 range, right? Kind of get that? See how that works? Now let's solve it. So how do I do this? I put 24 underneath 44, correct? 24 underneath 44. Look right there.
Above the 4 hours.
See on the Bravo ring, see 24, Cooper? Okay? So what's my rate? No, don't, here, look at that. Don't look at this, look at that. 24 is your time in your Bravo ring, so look at 24. Slide 24 underneath your distance of 44, right? Okay, now look at your rate. Does that make sense?
Wait.
There's no waiting.
I'm sorry.
Go ahead.
Just kidding.
So, what's the relationship between the Bravo ring and the Charlie ring?
It has, correct. It has to do where they take the minutes and now they put it in hours. Hours and minutes.
So the Charlie ring is hours with minutes, and then the Bravo.
We determined that on the first two problems, right?
Okay, I'm sorry.
It's okay. Okay?
Yeah.
It's, don't look at the times.
Oh, why is it not?
So do you,
Because those are hours.
all right, Steph.
Oh, that makes sort of sense.
Well, and you know what's so funny about that? Guess what it talks about on page 2? About the Charlie ring. Oh my gosh.
Mr. R, please listen.
Okay,
So then, I thought that 24 would be in between the two markers where it's like 9 and 110 would be in between there. Yeah.
but here again, if you did that and you looked at your rate, you'd know you're way off. You'd know that wasn't right. And this is why we solve these problems in our head first. Engage the supercomputer before we go to the little slippy, slidey, no batteries required computer.
Thank you so much.
Thank you, dear. Thank you very much.
Have a good day, guys.
Thank you.
You too.
Kind of starting to see how this works?
Yes.
Last one. Last one. Let's see. Now, don't get. Don't look. Don't look. Don't. That's your thing. Your rate is 95. Let's round that to 90. Okay? You're traveling now. Let's round that up to an hour and a half. Let's round that up to an hour and a half to make it right. You're at 9. Your rate is 90, and you're there for an hour and a half. Anybody get 135 on this?
Yeah.
Okay? In your head. All right, now do it. What'd you get?
Okay, so you get 95.
What?
You round down to 90. And then you
But I did get 150.
Yep.
So, so what's another way to say an hour and 24 minutes? 84 minutes, right? 84 minutes. Steph, what's another way to say an hour and 24 minutes? 84 minutes. 84 minutes, right? Take a look at your Bravo and your Charlie ring.
That's what I got for my mouth.
I know that's what you got for me. Oh, see, that's what I was telling you. You were using the wrong rate.
Yeah.
So did you get 133?
134, but yeah.
Okay, well,
Is that?
yes.
So that's 95 and that's 34. I got 134. It's like saying and I wrote 130.4.
A rate then. So you have your rate, which is 95.
So Steph, on that,
So you go to
can you fly on a heading? Can you fly at half a degree? Not on purpose.
Yeah, or
Speed-wise, can you do half a knot? Not really. So we always will round these up to whole numbers. Unless we start making conversions to Mach. With Mach, we start working with decimals, but that's different. That's a different thing. And you guys won't do that until commercial class.
Can you explain to me like the ratio of the last one for like 90 to what did we say?
Okay, yes, absolutely. So here we go. Take a look at a clock. The entirety of a clock is how many minutes? 60. Here's what I want you to do. Turn your paper over. Draw a circle. Okay? Now, I want you to draw a line from top to bottom. Split it in half. Now, I want you to split that in half. Uh-huh. Mm-hmm. All right. Now then, if you take a look at that clock and you know that there are 60 minutes in that circle, half of that is what? 30. Okay? If you take a rate of 90 and you know that half of that is what? 45. So it comes into fractions of an hour, and that's your relationship into your distance or your rate. Okay? That's what you use. So just like this, if your rate were 120, half of that is going to be what? 60, okay? Half of 60 is what? So you know the quarters now. So if you had 3/4 of 120, it's how many? 90, okay? So you can look at those. That's your relationship. Think of slices of the pie. That's what we're after here. Yes, dear?
So we're always going to be calculating these in the base 60 number system, like we're never going to be
Yes.
using radians or anything to
Not-
measure angles against.
Not on this.
Okay, because I was thinking like 1/60th is like 1 nautical mile, like 1/60th of an angle.
But you can look at this. When we get to the commercial class, we do look at this. And we start thinking in this in terms of calculating our top of descent. So we know that we're here and we want to be here at this altitude by such and such, either a time or a distance.
Yeah.
So with that, now we're calculating, now we're over here and we're doing trigonometry.
Right.
And so with,
Like a right triangle.
correct, because what we're trying to calculate is what is going to be our hypotenuse.
Yeah.
And that's what we're calculating. With that, we could do it with this.
Because you would put it in the circle with the reference
Yep.
triangle.
Yep.
Yeah.
So we could.
Okay.
It's not as precise as we need it to be.
Okay. I can see how that would be.
Okay?
But yeah.
Oh, right, yeah.
Now then, my children. We good?
Yeah, let's do this part.
Free
I guess it's
throws.
practice.
Free throws. I don't know how to do this stuff.
Now do the win.
Give us a really tricky one. See if we can get it.
We need to move to the wind.
I know. I can.
Oh, that's a whole other.
Okay. Now, for the following, you will need a pencil. Pencil, not a pen, but a pencil. Actually, Let me see if I have any more dry erase markers. Hang on here.
You're the only one that knows if I actually have my
Those are all. I don't know what happened to them. Okay. Well, all right, just use a pencil. All right, here we go. Shh. Now, conceptually, let's think about this. I've got you guys today until when? 9:40. Somebody make sure you stop me when I get going, because I get going on this stuff and I just don't know when to quit, which I've been told that before. All right, let's say this. Let's say, for instance, that what we're wanting to do is we are wanting to fly this direction. This is the direction that we're wanting to fly. And we'll just call this, just for the sake of just simplicity, we'll call this north. Okay? I want to fly north. Now, we have this odd phenomena here on our planet, this funky little thing about where air masses want to be in different spots. And when the pressure or temperature changes and these masses move around, we can sometimes feel that. And we feel that in the form of wind. Thank you very much. So let's say that as we're flying, in this condition right now, on a sectional map, we draw our line. That's going to be your true course, correct, Gavin? Uh-huh. We make our magnetic conversion with our magnetic variation to give us a magnetic course. So that dot across the ground, that is going to be our course line. In this case, we can convert that to a magnetic course, right? That's the ground track. Ground track. That's what we're after here, to fly that track. Now let's say, for instance, that our wind was blowing this direction. And let's say that with this wind, we're going to come up with a velocity and a direction. So in this case, let's say that our winds here are, stand by, let's say that our winds are 315 at 10. Y'all remember your METARs? 315 at 10, right? We're not looking at anything yet. We're just talking about this. So our wind on this course would be what we would call a left quartering headwind. In this case, our wind would be a left quartering headwind. Why do I say it's quartering?
Because it's 1/4 off the horizontal.
There we go. Everybody understand that? So in this case, it's going to be a left quartering headwind because it's on the nose. If the wind were from down here, what would we have? Left quartering tailwind. All right, good. Let's say that we had a wind that was like this. That's a headwind. If we had a wind like this, tailwind. It's very rare to have a direct tail or a direct headwind, but it can happen. So now, we know that we want to fly this course line. right? In order to maintain that track, what am I going to have to do to steer that airplane to fly that track? I'm going to have to angle my airplane to some degree to the left, but that's going to be based on what?
The velocity of the wind.
It's going to be based on direction and velocity of the wind, and it's going to have to do with my airspeed. Whoops, AS. It has to do with my airspeed. If I'm going faster, my angle will be smaller. I'll have a smaller angle based on my course. If I'm slower, my angle will be greater because I am exposed to that wind for a longer period of time. Conceptually, does everybody get that?
Yeah.
All good. Okay? Now, I'm going to show you something else. Get ready to draw. Draw this. This is going to be one sheet of paper, kiddos. One sheet of paper. And I want you to draw this identical to what you're seeing right here. If you have colors, this would be a great time to use them. Steph says, I got this. This is the world-renowned tool for you to use to do these calculations correctly. You will use this method for each and every cross-country problem that you do, or woe unto you. Every year, we think we have kids who have got this whipped. And every year, those kids give points back to the FAA. We're not going to do it. So now, do you have the top part?
Yeah.
Draw this exactly the way that you see it here. Remember, I don't give handouts. I operate on a hand-up basis. I help you do it yourself. I'm going to slide this down. We good? We good? All right, get this part. So on the left side of your paper in the center, you're going to have a big circle. Give yourself some room to maneuver there. Give yourself a big circle. You're going to want room to write on the right side of that circle. There's a reason that all this exists. Got this so far? Okay, I'm sliding down. There's your circle. This is the bottom of your page, lower left-hand corner. Lower left-hand corner, true airspeed, ground speed, ETE. Notice that in this, anything having to do with wind, I put in green. The reason I use green is because what color are oxygen bottles? Green. So we use that as kind of like air or wind and stuff, and so yeah. Notice that I always try to put magnetic variation in red. Why? That's what color it is. That's what color those isogonic lines are on your sectional maps. Magnetic deviation I put in blue to kind of match the circle. If you think of that circle as a compass rose, that will help you. So tell me when you have this all written down and I shall explain. Part of your homework this evening is to create a template for you to use. You will use one of these for every single cross-country problem that we do. You can make it reusable if you choose, but this is going to be your homework. You've got to make a template. I can hand this out to you, but if I hand it to you, I own it. If you create it from what you see, now you own it, and it's far more meaningful to you, Steph.
Can we make like a digital copy of it?
If you can use a digital copy with drawing lines and recording information on it.
Meaning like we would like.
If you want to do like a PDF, bring it here and then make paper copies, then yes, you can. Absolutely.
Like print it out and laminate it or something and use like a marker.
Whatever works for you. Did everybody get this?
Okay, what is
Hold on. Guys, did everybody get this?
not the very bottom?
Okay, and then the bottom.
Backside of these.
Front side of the E6B is where we do our time, speed, and distance calculations. The back side of the E6B is where we do our wind correction angle problems. Everybody good so far? Now let's talk about this. Upper left-hand corner of your papers. Two-finger airport identification. What does that mean? From and to. Do you realize that is half your battle? That is half your battle. Understanding what direction you're flying. From to. And guys, it sounds so incredibly third grade to do this, but I'm telling you, if you don't, story, what's going to happen? You're going to go the wrong direction. You're going to go the wrong way. And guess what? One of the three options will be staring you in the face when you're taking your FAA exam. The opposite direction. Do you know why? Because people do it a lot. So, two-finger method of identification. Second of all, general direction of flight. What is my general direction of flight? Next, what corresponding general heading goes with that? Everyone now has memorized your compass rose, correct? Primary, secondary, tertiary directions and headings, correct? Excellent. Then, once we get that general heading down and we lay that marker on the piece of paper, after we have checked it to the scale, our plotter, we've checked our plotter to the scale on the page, we're going to use the bottom edge to draw our line. When we're there, we check what? The distance. We get our distance. Do you need the distance for every problem? No, but you're going to record it because it's good practice. Then, if for whatever reason they ask you for something other than a magnetic course or a true course, there's going to be what involved? Wind. Magnetic course will be the same as your magnetic heading in a no wind scenario. So in the upper right-hand corner, when you see no wind, that line that you draw on your sectional map to give you your true course, then you make your adjustment for magnetic variation to give you your magnetic course. Your magnetic heading will be identical to your true course if there's no wind. Everybody understand that? But when the wind is blowing, and by the way, the wind is always blowing, your magnetic heading will be different than your magnetic course. Why? For the reasons that you just told me here. Is because you've got to turn that airplane a certain direction to compensate for the wind, correct? So the heading, the heading that shows up on your HSI will be different than the course you're flying. Right?
Right.
Okay? So this is how we do it when we have a wind problem. We still get our true course. We still need to know what our true course is. But we're not concerned now about the magnetic course because we know what it is that we're going to be working with here now. We know that the magnetic heading is going to be different. So with this, UC, TC, true course, then we get the information on our wind correction angle to get our true heading, and then we make our magnetic variation. Because remember, what are these winds going to be reported to you in? True or magnetic? They're going to be true. So we have to change something, right? And then to get a magnetic course, we have to convert that from what? From true course, so we have another magnetic change? The method that I'm showing you here right now is you do it once. You make one magnetic conversion, because the same magnetic conversion that you make for magnetic variation, you will make the same conversion for your wind, because presumably you're flying in the same spot. So we just do it once as opposed to doing it twice. Does that make sense, guys?
Yeah.
So we're only going to make the conversion once. Story, I see your furrowed brow. Do you understand?
Sort of. I got it.
To get magnetic course, we have to do what?
Yeah, you have to subtract the magnetic variation.
Well, add or subtract the magnetic variation, depending upon where you are. To get magnetic winds, what do you have to do? Add or subtract the magnetic variation. Well, you can do it twice, or you can do it once. The way I'm showing you, you do it once. It makes the math cleaner. But you have to remember what you're working with, what values you're working with. Then you get, with your plus or minus magnetic variation, you get your magnetic heading. Then you have something called magnetic deviation. What is magnetic deviation?
The difference in angle versus the actual magnetic, no? Oh wait, your instruments?
Keep going.
What your instrument reads versus what?
The magnetic.
Oh, in the
electrical
plane.
system
In the
interference.
plane.
Where's the
Yeah.
deviant? In the
inside
plane.
Yeah.
It's in the plane. The deviant is in the plane. So magnetic deviation happens in the cockpit. That is that difference. That's what that compass card means below your compass. Remember that part when we talked about our instruments?
And variation.
Variation is on the map.
Yeah.
Variation is an isogonic line. It's a line of flux. Magnetic deviation happens with the interference of the instruments inside your cockpit. So that's going to be something you read on your compass card, and from that compass card you get something called CH. What is that? Compass heading. You get a compass heading because your compass heading may not match up identically with your magnetic heading because of what?
Magnetic deviation.
Magnetic deviation. Below all of that, you see this thing called solve for. What are we solving for on this problem? You write that down because you want to make sure that you're answering the question. Then in the lower left-hand portion, you see true airspeed, ground speed, and ETE. What does ETE stand for? Estimated time en route.
Oh, wow.
Estimated time en route. Then you'll also see something below that. Anything having to do with a wind correction angle, you know that you're going to the back side of your E6B. Does this make sense here, my children?
Yes.
All right. Now then, what we're going to do is this the right one? I think so. So let's say, for instance, I am flying from Aspen to Rifle. Two-finger method of identification. What is my general direction of flight?
From where?
Northwest.
From where to where? Aspen to Rifle, northwest, right? So I'm going to fly this direction, correct?
Yeah.
Roughly northwest. So I'm going to write down on that sheet, general direction of flight, NW.
Okay. On this sheet?
It's up to you. Just remember, you're going to create a template tonight. So we're just doing this for the basis of this particular problem. General direction of flight, we're going to call it northwest. Give me a heading, a general heading that corresponds to that general direction of flight. Tree 15. Tree 15. So we're going to say tree 15. GDOF is northwest. General heading is tree 15. What do you want next? Distance. 44 nautical miles. Next. What does it ask? Okay. Wind direction and velocity. Now then, your wind is from tree 50 at 15. You'll notice how I'm doing this. Looks like a METAR, right? Wind, tree 50 at 15. So you're going to write that down. But you're also going to put an arrow against your proposed general direction of flight. And here's why you're putting that arrow. What kind of a wind do you have? A right quartering headwind, correct? Right quartering headwind. So what direction are you going to need to steer that airplane? Left?
No, right, sorry.
I'm going to steer it to my right. When I steer it to my right, what happens to the numbers on my heading? Do they get bigger or smaller?
Bigger.
They get bigger. They get bigger. As I turn to the right until I pass north, the numbers are going to get bigger, correct? Okay? So what do I think is going to happen to that number ultimately?
Bigger.
It's going to be bigger. Ding, 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 ding. Got to make sure I remember that, because I know that number is going to be bigger than what I think, because I'm going to have to steer the airplane to the right in order to fly that track, correct? Good so far? Okay, now I have to get out of this sheet here. I apologize. But this is what you write down in your circle. You draw this on your circle. And the reason that you draw the imagery is so that you get the problem correct in your head. Okay? Now, I'm gonna get out of this because I'm not smart enough to figure this part out. So let me ask you this. Now that I know that there's wind, is the upper right-hand corner of this going to help me at all? Negative. So I know that I need to come down here to this part, correct? Okay. So we're going to talk through this. Oh, come on. So the first thing I want to do is what? I want to get my true course. So what do I need to do? Get my map.
Get the map.
Line this. Well, no. We're talking through it. I'm going to line this up, draw my line. This is where I get my distance, correct? Okay. I've got my line. Now I'm going to determine my true course, correct?
Yes.
Okay. So let's say that my true course, what did you guys get on the last one with your problems? Who has them handy?
I can get them.
True course. What'd you get, Diego?
294.
294. 294 degrees. True course of 294 degrees. That's your true course. What's next? Wind correction angle. So to get our wind correction angle, where do we go?
Backside.
Backside of the E6B. All right. So let's go there. I didn't think I had turned this off, but evidently I have. Shoot. Oh, come on. That'll about do it on that, I think, probably. Okay. There it goes, hopefully. Come on. Come on. Work for Daddy.
Here we go.
Let's go.
And go.
Positive energy. Come on, people.
And 9, 8, 7, 6, 5, 4,
Why is this taking so long?
10. 10 minutes. 5, 4, 3, 2, 1.
I don't know why this is frozen. Darn it. All right. Turn to the back side of your E6B. Got it, Tyler?
Yep.
All right. On your E6B, on the back side, you will notice that you have a clear, kind of a translucent kind of a covering on there. I don't know what is going on. It's just, I don't know what's happening. The mouse is just, I have lost control of my machine.
Machine takeover.
I don't know what's happened here. Honest to goodness. This is just not good. Not good. Stand by. This is so upsetting. It's trying to come up.
I guess this is why we wanted to do
Okay, now, on the back side of that E6B, you'll notice the translucent cover.
Yeah.
You'll notice that you have a little spinny thingy in there, okay? That's something that you can kind of move around, okay? But now, here's the really cool part. Well, there's actually a couple of cool parts. First of all, how many of you remember that little hole that's in your plotter? What do we call that? A grommet. Thank you, Gavin. How many of you notice a hole in this Lexan cover? There's your grommet, okay? So you have a grommet that you need to work with here first. The very first thing that you're going to do before you begin work with this is you are going to put your grommet on an index mark. The index mark that you're going to use is 0. But you'll notice that there really isn't a 0. But what is there?
100.
There's 100. Thank you. Put your grommet on the 100. Yep.
Find it.
Put your grommet on the 100. Do you guys see that?
Why are we doing this?
Because I told you to. Don't I sound like a dad right there?
Yeah.
Because I just said so. Guys, grommet on the 100. It's going to be lower, easy. Grommet on the 100. That's where we start. Okay? Now then, at the very top of your E6B, you'll see a black box. Tyler,
Yes.
read for us what is on line 1.
Set wind direction under true index.
Say again.
Set wind direction under true index.
So number 1, with your grommet on that 0, you want your wind direction under the index mark. So slide that around until you get what under your index mark? 350. Your winds are 350 at, what'd I say, 15?
Oh, wind direction.
350 at 15.
350.
I'm going to relaunch this because something is just really, really wrong here. So you put your wind direction under the true index, okay? Got that? So under that true index, you should have tree 1, what did I say? Tree 50. Okay, now, Cooper, read number 2.
Mark wind velocity up from center point.
Mark wind velocity up from center point. The center point is where you have indexed your grommet. So now, what you're going to do is you are going to, from the top of your grommet, you're going to go up how far? 15. So you're going to put a pencil mark at 15. So you see where the 10 is? You're using a pencil, correct?
Yeah.
Okay. So there's 15. There's 110, there's 120. So that's going to be right in the middle. Okay? Got that so far? So you've got 15 up from that. Gavin, read number 3 for me, please.
Number 3, set true course under true index.
Set true course now under your index. So you're going to spin that spinny thingy until your true course, which is what?
294.
I thought it was
True course. No.
294.
294. 294 is your true course. That's the line that you drew. Your general direction of flight was 315. But you measured it out and it came out to 294. Now,
Oh.
true 9 or 4. Do you see that where you have 2, 9, or 4 underneath that index at the top? What direction now is the dot that you drew? What direction, Easy? To your right. What direction did I say you were going to have to steer? To your right. Ding, 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 ding. Okay? Now then, number 4, Diego.
Slide wind velocity mark to true airspeed.
The dot that you drew is your wind velocity mark. Your true airspeed, which is going to be given to you in the problem, and I will give it to you now. Your true airspeed is 120. Your true airspeed is 120. Where do you write that down? The lower left-hand corner, you'll see a thing called true airspeed. I'm sorry. No, where did I put it?
yeah.
Lower left-hand corner. True airspeed. 120. So now, you slide that dot, you keep everything there, keep your thing lined up. Don't spin it anymore because it still should be lined up with an index of 2, 9, or 4 based on this problem, correct? Slide that until that dot that you drew is on 120. There's an arc that'll be for 120. Okay? Easy. Read number 5 for me.
Right. Ground speed reads under center.
Ground speed now will read under your grommet. So look at your grommet and see where your ground speed comes. What is your ground speed? 111. Write down your ground speed, lower left-hand corner. Now, let me ask you a question. What kind of a wind did you say you had?
A left quartering.
Right quartering headwind.
Right quartering headwind. So do you think your ground speed is going to be less than your true airspeed now? Yes, because that headwind is slowing you down, right? So your ground speed now will be less than your true airspeed. Does that jive? Ding, 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 ding. Yes. Okay? Now then, number 6. Harris, can you read number 6? Are you able to speak?
Not really.
Okay, then don't. Story, read number 6.
Wind correction angle reads between center line and wind velocity mark.
Take a look at the longitudinal line on your wind thingy. Okay? Now, count to the right how many tick marks you have.
3.
Okay? You've got 3 tick marks.
Yeah.
But if you look at that, those 3 tick marks mean what? They're 2 each, correct?
Yeah.
So it would be 6. So you have 6 degrees to the right. So what do you do with that? Look here.
Because it's right, you add it.
You add it if it goes to the right. Because remember I told you if you're steering to the right, what happens to that number on your HSI? It gets bigger. So we're going to add it. Okay? We're going to add that to what? 2, 9, or 4, right?
Yeah.
So your wind correction angle is going to be a plus 6 degrees. So where does that go? Look in your lower right-hand corner. Look in your lower right-hand corner. You've got your true course of 2, 9, or 4, correct?
Yeah.
You have then your wind correction angle of a plus 6 degrees, correct? Yes. What is your true heading? 300. There is your true heading. 300. Now then, you notice I have kept everything true. Have you noticed that? I kept everything true. Everything you put in this circle is true. Everything is true. Your course and your wind direction are both true.
Right.
Now, once you make your magnetic variation correction. So, what was the magnetic variation? 10 degrees east, correct? Okay, 10 degrees east. Write down your magnetic variation, 10 degrees east. It's on the lower right. 10 degrees east. What do I do with east?
Least.
Least, you subtract. So what do? I subtract 10 from what? 300. What do I get? 290. 290 is my what now? That is my magnetic heading. That is the direction that I have to steer my aeroplane in order to follow that line that I drew on that map, based on the current wind conditions. Now then, what's next? Magnetic deviation. If it calls for a compass heading, what do you have to know? You have to know your magnetic deviation, which comes from your compass card. If the question does not ask for a compass heading, but it just wants a magnetic heading, you're done.
So will they give us?
Yes.
Okay.
Yes. And they will tell you, refer to figure blah, 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 for that compass card. And you have to make that direction. So let's say, for instance, that compass card said for a magnetic heading of, what'd you get? 290? So let's say for a magnetic heading of 270, steer 272, you would add 2 degrees to that.
Okay. So.
But we're not doing that because I didn't ask that question, because I don't want to be I don't want to make this part up. Okay?
Okay.
Steph?
Was the magnetic variation given to us?
It was on the map. It's what you guys did on your maps.
Okay.
So we'd have to use
Okay?
Yeah.
We have to use the map
Oh,
to get
class
all
is
the
almost
information.
over, but
Okay? Now
yeah.
then,
Tonight we're gonna do all those. Yeah. No, I like this.
This is kind of fun.
here's your homework. Do you remember all that stuff that you did with getting your magnetic course on all those different routes?
Yeah.
Write down the following.
You still have 2.
Yes.
Your wind, and this will apply to all of these problems. Your wind, this will apply to all of these problems. Ready?
Yep.
Winds 090 at 20. You have read this wind from a METAR. It was not spoken, it was written.
Magnetic.
If it's spoken, it's magnetic. If it's written, it's true. So remember, winds 090 at 20. Remember, that's true. And I also want your ETE for every single one of those. That is your homework for tonight.
So ETE is calculated.
So now what do? Now that you know your ground speed,
Yeah.
what can you do? So now you've got your rate, now you have your distance, now you can determine your time en route, your estimated time en route, correct? With all of this newfound knowledge.
Okay. I like it.
Off you go.
So you line that up with 120.
Are these two we use ground speed or true ground speed?
Oh. Stand by. I'm sorry. Thank you. Your true airspeed. So your winds, 0, 9, or 0 at 20, correct? Is that what I told you?
Yeah.
0, 9, or 0. Your true airspeed for these, 115. True airspeed, 115 is your true airspeed.
For all of them?
All of them. It applies to all of them. True airspeed, 115. Guys, you have until Friday.
Since we're not here, should we just turn it into Miss Benton on Monday?
Yes.
Okay.
Now here's the cool part, guys. The cross-country stuff that you guys are doing right now, this is where you are really beginning to start tying everything together. This is when stuff actually kind of starts getting fun. You have your guides to work with, should you need them, right? Okay, any questions? And let the record show that we all agreed today we're going to start doing our homework.
You have it on video.
Okay.
Wait, to find the true airspeed, you set it to 100
No,
first.
no, not to find your true airspeed. Well, I give you your true airspeed, but you slide your mark to the true
Oh, you
airspeed.
already know it. Oh,
It's given. The true airspeed's given
Yeah, your wind goes up.
under the grommet.
Say your wind is at 16 knots.
So if it's at 120?
Down to 100.
So for instance,
So your wind is up 100, so your wind is like 20 knots. And you put your thing at 100 and you mark it at 20.
yeah.
if this is the mark that you drew
That would be your
here
airspeed.
for like your wind velocity here, and then you rotate this to
Yeah, just FaceTime
your
me.
true course on here, and then it shows set the wind velocity mark to the true airspeed. I said 115, correct? So you'd slide this to 115, okay? But again, this is assuming that you started with your grommet on your index mark.
Okay.
Guys, one last thing. The most common error is made at the very beginning by not putting your grommet on the index mark. You have to begin this problem with your grommet set on 0.
Yeah.
That is the most common error, is not beginning at 0. It, of course, has been my pleasure. Good luck this weekend, kids.
You guys are gonna kill it.
Go kick some ski or bootay.
Staff feel better.
I'm feeling dependent. I barely talked today.
And
And I barely noticed.
kill the skiing game. Thank you.
Gavin, have you guys filled out?
We're all leaving. Go freshmen. Woohoo!
Have fun. Good luck, guys.
Good luck. Good luck, guys. Kick some bootay. Guys, did you on this? Have you filled that out yet?
No, but I have it, so.
Okay, bring it. Bring it. We got to get you going. Easy. Do you have that? Okay, depends on what you're doing. Okay? So whatever you want to do. So we need to get this going. Okay? Off you go. Okay, Cooper, do you have a rental agreement? Rental agreement to start flying. You going to start flying? It's time.
I would love to see.
It's time. Let's go.
Thank you, Mr. R.
You have this?
Yeah.
Okay.
I do.
Okay. All right.
Thank
Okay.
you very much.
All right, guys. See ya.
I'll text you when you're gone.
Let me know. And we'll do the FaceTime thingy.
Yeah, sounds good.
Okay, hon.
Thank you so much. Bye.
See ya, hon.